When things are exposed to cold temperatures, they normally contract. Water is different in that when water freezes, it expands by about 9%. Doesn't seem like a lot, but that 9% literally will expand at phenomenal force, several hundred pounds per square inch. So literally, it becomes a very effective method of breaking down surface materials. How many of you have dogs? Who's got an outside dog? Oh, great. The rest of you have house rats. How big is your dog? Is he out? He's outside most of the time in the winter? All the time. So when you're told to go and give water to that dog, how do you provide water for him? You don't care. Oh, who has an outside dog they take care of? Okay. You get this nice container, you throw water in it, and it gets cold that night. What's going to happen to water in that container? Freezes. Oh, you forget about it and come back 2 weeks later. What are you going to find in that container? Solid block of ice. So you throw that out, and you go to fill your plastic pail, and what do you find? Where? No. You find a hole in the bottom. Why does it break at the bottom? If you don't do a plastic bucket, but you take one of your mom's best pots, fill it up with water, put it outside, what's going to happen to the bottom of that pot? It's going to have a nice low round. Some of you say, yeah, you must have done it a time or two. It rounds out. I mean, you don't have to say that your kid, brother, or sister did it. But basically, it's trying to push out the bottom. Why does it happen there and not at the top? Here's your plastic bucket. Or your pot, you take whatever you like. There's your water level. Why doesn't it just shoot up? Yes?
Doesn't it freeze at the top first and just keeps pressing down?
Why does it freeze at the top first?
Because it's not close to here.
Okay. Freezes at the top first because you have maximum radiation loss off of the surface. You don't have anything hindering it. Where's the next place it's going to cool off or freeze? You've been off the sides, but again, radiation loss off the sides. The last place this bucket of water is going to freeze is on the bottom because it's against the earth, and the earth is an insulator. And so it will lose energy, but very slowly out the bottom. So what happens over a period of time is it begins to freeze. And so you form this massive cap over it. And when that last segment freezes, literally, and expands, it has no place to go but down, and it just simply fractures the bottom or creates a bowl shape on the bottom of this pot pan. If you don't think this works, experiment tonight, next couple of nights, see what happens. Odds are you're going to have a leaky container, and please do not take your mom and dad's pot. So, ice has a very, very effective and forceful means of weathering. So, first step of weathering, growth of ice crystals. 9% expansion, hundreds of pounds of pressure per square inch. And it results in a physical breakdown of the rock unit. For those of you that have traveled to the west, and you another diagram. Travel to the west. And you've seen the Rocky Mountains. What happens, water gets into various fractures, cracks on the sides of the mountain, freezes. When it freezes, it expands, and sediment particles come cascading down off of it. Physical weather, all you've done is reduce the size of the rock mass. Accumulates at the bottom in this nice apron, and the material is called talus, and this feature is called a talus cone. Formed by physical weathering, frost, or ice crystallization. 2. Oh, by the way, what happens to highways in the winter months? What? They crack. What little features you find in cement and asphalt roadways in the winter and early spring? Potholes. Ever say, well, how did potholes develop? Odds are you blame the contractor who laid the cement or who laid the blacktop and said they did a crummy job. But basically what happens for a pothole development is growth of ice crystals. What is that process called when something lifts off because of freezing conditions? Ever heard of frost heaving? Frost heaving is when things are displaced by freezing conditions at or near the surface. Here's your handy dandy roadway. Nice blacktop surface. Water gets through this, through all the cracks that are in the roadway. The water is trapped between that and maybe a layer of clay or some other material. When this water freezes, it has two choices. It can either push the earth away or it pushes the blacktop up. Odds are it's going to push the blacktop up. So what you end up with initially is a low bubble. You're going to say, well, that's not a pothole. But if you drive over it often enough, what's going to happen to this bubble? It's going to break down, and now you have a cavity formed. You're exposing the gravel below it. And so frost heaving and growth of ice crystals really destroy our roadways here in central Wisconsin. Okay, back to 2. Development of frost crystals. What? Salt crystals, right? Oh, I said salt crystals. Sorry about that. Development of salt crystals. This happens only in semi-arid environments. Semi-arid environments. How many of you have been to Mesa Verde? Anybody know what Mesa Verde is? Chaco Canyon? Yes, Mesa Verde is. Okay, Mesa Verde is actually southwestern Colorado. Chaco Canyon's New Mexico. But what's unique about them?
They were inhabited by natives.
Okay. The cliff-dwelling Native Americans were in this area. They literally lived on the sides of sedimentary structures. And they lived on the sides of the sedimentary structures because salt crystallization formed these features. In the southwest, there are various features that look something like this. And if we look at these various layers, so what kind of rock unit probably? If you have horizontal layers, what? Sedimentary. So you have these sedimentary rock layers. If the first one is a sandstone, and this next one is a shale, we really don't care what's below that. Sandstone is permeable, meaning that water will filter on through. Not all of the water, but some of the water is going to filter on through sandstone. Shale is impermeable. It's almost like your countertop. So when the water gets to this point, it's going to flow along the impermeable layer. And the word flow is really misused there. It literally just creeps along at a snail's pace. It may take centuries for that water to go down through, hit the shale, and move to the edge